Hello, this is Miss Pat from Samuel's Public Library. This week we're going to learn a little bit about earthquakes. Our book this week is called The Quicksand Book by Tomie dePaola. We'll find out later what that has to do with earthquakes. So there's the jungle girl. Help! Hello, jungle girl. My goodness, you look very unhappy. Is it because you have fallen into quicksand? Well, don't worry. It just so happens I know a lot about quicksand. So look and listen carefully. It'll be very interesting, and you might learn something. First of all, quicksand is not a special kind of sand. It is plain sand, but when water is forced up through the sand, the grains are pushed apart, and the sand swells when this happens. The sand is no longer hard and cannot support heavy weight. That is why you are sinking. When the water stops or drains, the quicksand becomes plain sand again. It's pulling me down. No, that's not true. Quicksand does not pull you down. That's movie stuff. Instead, the weight of your body is making you sink. And if you struggle, you will sink faster. So stay calm. You see, when you struggle, you push more quicksand out of the way and you sink faster. I noticed that most people, if they stay calm, they only sink up to their necks. If you had fallen on your back, you could have floated on top of it. The same way you can float on top of the Great Salt Lake or the Dead Sea. But it's a little late for that now. Could you help me out, please? In just a minute. I want you to look at what happens to animals if they happen to wander into quicksand. Horses usually leap out in short, rabbit-like jumps. Mules lie down on their bellies with their feet tucked underneath, then they don't sink. Cows need help because they panic and sink quickly. If you knew how to watch out for quicksand, you wouldn't have fallen in. You should have carried a long stick or pole to test the sand first. The quicksand would have rolled like waves if you had done this. But the vine I was swinging on broke. Remember, she wasn't walking in the jungle, was she? Jungle boy, I'm up to my shoulders. Help me out. If you had been carrying a stick or a pole, you could have gotten out like this. Read the chart carefully. These facts are very helpful if you are alone and if you have a stick with you. 1, call for help. 2, fall on your back. 3, put the stick under your shoulders with the arms out to the side. 4, push the stick to your hips. 5, slowly pull legs out one at a time. 6, don't tire yourself. Take rests between these moves. 7, use the stick to keep floating on the quicksand. 8, roll a little at a time to solid ground. 9, rest. Jungle girl, this is your lucky day. I'm here to help you. I could stretch out on that log and pull you out with my hands, but that would take a lot of work. Instead, I will use a strong vine. Slip the vine under your arms and hang on. Oh, jungle boy, thank you, thank you. You're welcome. Next time, don't be so careless and watch where you're going. Oops. Help, help. Now, remember what you told me. Just keep calm. Lie on your back and float. I'll pull you out when I finish my tea. So, it is possible to float on quicksand, but we're going to find out now. What does this have to do with earthquakes, right? So let's see. First off, let's find out what earthquakes are. Okay, so we know there are different layers on the earth. The top layer that we get to stand on is called the crust, right? And it's not one solid piece. It's like 20 puzzle pieces. Each puzzle piece is called a plate, and they are constantly moving. Fortunately for us, they don't move very fast. We're standing on them, right? The fastest plate might move about 6 inches a year. That's about as fast as your hair grows in a year. Right? 6 inches, that's about this far. So really, it's only going from here to here in a year. Earthquakes happen, though, when a plate bumps or drags along another plate. So just dragging along makes the earth shake a little bit. But I want you to notice this one before we go on to the next slide. We live right here, in between, right above where it says Caribbean plate and underneath where it says the North American plate. We live right here. We're in the middle of that puzzle piece. Now, California is right here on the edge of this puzzle piece. California gets a lot of earthquakes, like a lot of earthquakes. All earthquakes produce 2 types of waves, right? One is a P wave and the other is an S wave. The P wave, this top one, is kind of like a slinky. And if you just hit the end of a slinky, it just kind of goes woo, woo, right? It goes right back and forth. Notice this one, you can see the waves kind of going this way. It'll go through solids, liquids, and gas, and it's the fastest wave in the earthquake. Shortly after it gets to the seismograph, and we'll talk about that in a moment, comes the S wave. The S wave is a little bit slower, and it only goes through the solid rock. It doesn't go through liquid. If it hits the ocean, it stops. Hits a lake, it stops. Okay, but this one will go through all the rock, all the land, and it kind of is like a jump rope when you're playing back and forth with it, and it's kind of going like a snake. Those are the 2 types of waves. Now, a seismograph is what records the P and the S waves, and it tells us the intensity and the time in between it. So the one up on top is a little bit more like a real one, right? And you can see these lines going back and forth. They got a heavy weight here. This would be the seismogram where it's recording it. This is one that you guys can actually make if you put in a do-it-yourself seismograph. If you Google that, you can make a cup with a marker in there, and you can pull the paper through the box, right? And it'll make these lines on it. Now, they have to have 3 different types of seismographs in 3 different locations to figure out where did this earthquake start. We know we got hit by an earthquake, but where was the starting point? So by having 3 of them and knowing how long it took the waves to get there, they said, well, where these 3 circles meet, and they draw the circles around it, that's where the epicenter is. The epicenter is where it started. Now, why do we need to know anything about earthquakes? Well, it helps to know when we want to build houses, where we want to build houses, helps to know how to stay safe if one happens, right? Because we don't want to be running around and having things fall on us or falling into the road. These are some of the pictures. These are pictures from Virginia. We had an earthquake about 11 years ago. And all the food fell off the shelves. Ceilings kind of fell down in this building. And look what happened to the road. The car kind of sank in it, huh? So we're going to talk about that today. That's what we're going to do with our project. It's called liquefaction, right? Liquefaction means the soil, the dirt got turned into a liquid. The key ingredient is a loose sand. Sand grains can be packed in a loose or a compact dense formation. The loose sands can have considerable weight on top, as long as there's water there. Forms a good portion of the mass, but an earthquake is going to shake it. And I want you to look at these sand grains right up here. They're kind of balanced on top with lots of water there. Once it starts shaking, these grains kind of fall down. There's less water there, and now it's kind of less stable. So now it's kind of floating on the water, and the water is going to kind of come up to the top, and our buildings are going to kind of fall down. Okay, so they have bedrock, so the water can't go down any further because it's stuck on top of bedrock. So the water's going to come up. Now, you probably can't see the pictures, but the water came up here on top of the ground, on top of the sand. So when they built these buildings, here's the sand. Look really tight, really firm. You could put buildings on top of it, but then not so much. So here we kind of, looks like mud. We got a rock on it. Shake it a little bit. The rock sank and the water came up because the water is going to come up to the top. Sand's going to stay down. Here's blocks, kind of like buildings. And when they shook it a little bit, we ended up with a giant puddle and the buildings kind of moved. This is what happens during an earthquake. So we kind of need to know this kind of stuff. Are we building it on wet sand that's going to move? We don't want to build a house there, right? Because if the ground shakes a little bit, our house could move. That's not safe. This is why people learn about earthquakes. So if you want to do this, I have a little pan and I have a cup of sand. Right. First, I'm going to get a thing of water. I'm just covering the bottom. Okay. Now, I'm going to mix some sand in. Stir it up. Still looks very mushy, doesn't it? I'm going to pour some more in. All right. I got a lot of dry stuff over here, so I'm going to put a little bit more water in because I can't get it to mix in. Okay, and I'm just going to pat it down. Because I got wet sand. And we're going to build a house. I'm going to see how well that works. Okay. Now for my earthquake, I don't want to start going boom, 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 and shaking everything all over the place, okay? I'm going to turn this sideways. I'm going to kind of go, not a good spot, huh? And I'm just, whoa, my building came down. Well, that's not good. So we're going to do something different with my. Right. So now what I want you guys to do, and you ask permission before you do this, okay? You're going to take a little bit of icing. Okay. If you're not allergic to peanut butter, you can do it with peanut butter. Okay. But I did icing because I know that a lot of people have allergies to peanut butter, right? So we're going to take, I gotta get my knife. So here's my knife. I'm going to take one of my Starbursts, and they're in the wrappers. Okay, and I'm going to, this is the open side. I don't want the open side down on my sand because I want to be able to eat this later, right? So I'm going to put my icing here. Notice I'm only using a little bit of icing. Okay, and I'm going to put my other one right on top. Kind of like the first house. Think of the three little pigs, right? First one built their house of straw, fell down easy. Next one built it of sticks. Didn't fall down as easy, but it still fell down. Last one built it with bricks and cement. So I'm going to kind of cement these together. And again, I don't have a lot of icing all over it, but dropping it. Okay. Well, maybe now it won't fall so easily. Right? I'm not going up and down the sides. I'm not icing a cake. Okay. I'm going to put it there again. All right. Remember, we're going to do this. Now we're just going to keep going from the sides. I don't know if you guys can see. I can see. I got water back here. You guys can see the water back here. Try to go from this side. Right now, my thing's not falling over as much, but I definitely have water. That's liquefaction. It's kind of like quicksand. Sometimes if you have bones, dinosaur bones underneath and stuff, this is when might come up. Because the sand is going to sink lower, the water is going to come up and might bring up stuff underneath. Now my building is staying up a little bit. Again, why do we need to know about earthquakes? So we know how to build. Right? And I'm not shaking the whole thing, right? I want you guys to know I'm not going like this. Okay. I'm just going like this on the sides. This is very, very mushy. Kind of looks like quicksand, looks like mud. My house is kind of sinking into it, isn't it? Now, the thing is, my house is built a much better now. It didn't fall off one floor at a time. Now, what you guys could do with this is you guys can get more. You can try and build it fatter. You can try and build it higher. How high can you build it before it'll fall over? Remember, this is getting mushy, so eventually it's going to sink. Okay, and that's liquefaction, and that happens from earthquakes. This is one of the reasons they have to know what they're building on, because you don't want to build on an area that's going to do that when the ground shakes. So this is why people have to learn about that kind of stuff. Now, if there ever is an earthquake, going down into the basement is a bad idea, right? But going into a doorway frame, okay, I'm going to show you a doorway frame. When the door is open, obviously, when the door is open, because you got that wood over you, and that'll keep anything that's falling down from the ceiling from hitting you. You also go down and you cover your head so that your head doesn't get hurt, okay? And that's one of the things you do for an earthquake. Like I said, we had one in Virginia 11 years ago. Ask your folks where they were. Most of them might remember it if they were here in Virginia. And they could feel it all the way up in New York and all the way down to Georgia. But it started in Virginia. We even got a crack in the Washington Monument, okay, in DC. They got a crack in their monument from the earthquake, but it started in the middle of Virginia. Not here in Front Royal. It did start in the middle of Virginia. I didn't hear, though, of any liquefaction except for the cars, the roads. Some of those, especially near the rivers. Okay, so I will see you guys in a couple of weeks. Have fun.